Good afternoon, dear students. Welcome to Module 2 of the subject Introduction to Data Structures and Algorithms. In the last class, we discussed about Introduction to Data Structure, and we discussed data structure is nothing but it's a collection of data elements, and these elements are called members. These data elements are also associated with a set of operations. So they are called data structures. So we discussed the various characteristics of data structure. Data structure normally representation of data in the computer memory. That is first point. Second point, it provides the logical relationship between various data elements. Third point, it helps in efficient manipulation of stored data elements, and it allows the programs to process the data in an efficient manner. These are the four characteristics of data structures, and we discussed the data structure is divided into primitive data structures. Primitive data structures are those which has the primary data elements. Primary data elements like integer, character, float, boolean, etc. Non-primitive data structures are derived data structures from the primitive data structures. So they are of two types: linear are the one they get allocated to continuous memory allocation, that is one next to each other. Non-linear data structures, they are allocated at different locations of the memory. Example for linear is your arrays. Non-linear is your trees. And we discussed the data structures, different types of data structures: arrays, linked list, stack, queue, trees, graphs, etc. And data structure operations include traversing, searching, inserting, deleting, sorting, and merging. And their uh, efficiency also we discussed. And in today's class, we are going to talk about the first data structure, that is arrays. As you know, array is a collection of data items. These data items are of same type, and of course they are accessed using common name. And following are the characteristics of an array. First one, it uses a single name for referring all the array elements. Second one, um, it stores different elements at consecutive memory locations. Third one, its name can be used as a pointer to first array element, and its size is always a constant expression and not a variable. It does not perform any bound checking on its own, but we have to write exclusive program to implement it. Next, these are some of the examples of the array declaration. So you can declare array with the size. So 10 elements are having same name and they are of integers. And you can have 1,000. And of course, here you observe here this particular line, very important. Uh, so we have created a pointer and an array of size 10, and the first array element is nothing but ARR. The name of the array itself is the first array element, and it is being pointed to the array PTR. And of course, array element size are constant. You observe here they are totally constant. And of course, when we talk about two different types of arrays, one dimensional array and second one multi-dimensional array, Multidimensional array where we work with array of strings or uh, the matrix operation, matrix creation, representation, respectively. Single dimensional array, single array. So, uh, we now let us focus on implementing and manipulating of one dimensional array. So, uh, before we actually start its operations, let us look into how exactly they are represented in memory. You observe, we already discussed that whenever an array is declared in the program, the continuous memory is allocated, and the initial address or the first element address is called the base address. And each element will occupy the memory space required to accommodate its value, that is depending on its data type. And the next successive memory address is allocated to next element in the array. The process of allocation will continue until the number what we have specified in the declaration of array is uh, satisfied. So here is one simple example where ARR of 5. So it allocates 5 elements. So, and observe 600, 6,000 is the base address, and every time consecutively it changes 602, since it is an integer. So it is 602, 604, 606, 608, etc. So it allocates for different. And you can also calculate its memory representation using this formula of the array of any particular element. A of k is equal to b plus w into k. What is w? W is nothing but word size. B is your base address. Base address is nothing but address of the first element. So first element of the array, we call it as the base address. And k is nothing but the index number of a particular element. So we call it as k. And of course, we can certainly work on all these things, and we'll find. So here is one example to find the index number 2, array index number 2's address you have to find. So for this, 6,000 is the base address, 2 is the word size, that is the size of integer, and 2 is your k, that is index number. So by doing all this calculation, you can certainly do this. You can find the memory location of this particular array. So that is one thing. Now, before we move on to the next, let us look into a checkpoint. So here, what is a base address? Base address is nothing but it is the memory address of the first element of the array. And how are the array elements stored in the memory? The elements of the array are stored at the consecutive locations in the memory. So that is what these 2 points that you should understand. And of course, remember, uh, next term is array traversal. Array traversal uh, is one very important concept. So whenever we are working with arrays, it is often required to access the array elements, that is reading the values from the array, that is achieved with the help of array traversal. It involves visiting the array elements and storing or retrieving the values from it. And some of the typical situations where array traversal may be required are printing of the array, sorting of the array, searching of the array, etc. So here is the question. Normally, before we move further, we'll think about what is array index out of bound. Array index out of bound is a runtime error. Observe here, it's a runtime error that is going to that is encountered when a program tries to refer address location outside the defined array limits. So if you have defined array of size 10, if you are trying to refer to 11th location, then this array uh, index out of bound runtime error will occur. So it is most common in Java programming. And algorithm to traversal. So here have you named the algorithm as a traverse, and ARR is the array, and size is the size of the array. So you create a variable I, uh, you repeat step 4 and 5 such that the value of I is less than I. If value of I is less than the size, so what happens? It has to access, that is, it has to print, then it has to increment the value of I. So this will repeat 4 and 5 step will repeat until the size uh, is bigger than I. Once I is equal to or greater than the size, so automatically it stops. So during this process, what happens? You might have visited all the array elements and accessed the same program. uh, Algorithm is converted into a program. Same algorithm is converted into a program where you have declared the function, and you have created an array and size 5, and here you are printing the message array traversal and displaying of elements. Later you are calling the function by passing the base address ARR and the n, the size you are passing. So as soon as you do that, what happens? Array is a pointer that is pointing to the first element, that is 2, and the size will be 5. And you create a loop I is equal to 0, and until I is less than size. So you keep on incrementing, meanwhile you printing the values of array of I. So by doing this, you will traverse. Anyhow, this program will execute this program, and also we visualize. This program will execute and will visualize. Let us execute this program. So yeah, you can see the execution of this program. I have typed the same program here, and as soon as I run this program, so you can see the output I get. The array traversal and display its elements. So it has traversed 0, 1, 2, 3, 4, and so all the elements. It has traversed all the elements. So that's the thing. Now, how exactly they are visualized in the memory? So let us look into this another example code where I visualize the same program memory. What happens? How exactly it is going to display? We'll see that. We'll try to create an array. So you see, as soon as I execute line number 5, I got the elements stored into an array. Later, n is created with value 5, and I am trying to print the values of the array. And you can see, so as soon as I pass the ARR into array, so what happens? Array is a pointer which is pointing to ARR base address. With the base address, I am trying to print array of I. So that is 0. 0 means the first element. 2, 1, 2, 3, and 4. So all the elements got displayed, and you can see simultaneously they are also displayed. So this is the program that demonstrates the traversal of the array events. And further, there are other techniques also. The basic initialization has the size and the elements of the array. So what happens? All the elements will get stored into this array, And of course, the second one, initializing without the size. So whatever the number of elements that you have, so that will be the default considered as the size of the array. So it can be done like this. And partial initialization, you specify the size, number of 5. That is, the array size is 5, but you declare, you specify only two numbers, 3 and 7. What about the rest automatically becomes zeros. So this is partial initialization. Next one is initializing all the elements to zeros. So if you have lots of number is the array with the 1,000 size, and what happens, you just write 0 in curly braces and semicolon. So what happens, all the elements gets initialized to 0. This is the uh, one variant where you can initialize all the elements to 0. So next, before we conclude today's class, let us discuss what is array traversal. Array traversal is nothing but it is a task of visiting the array elements and storing or retrieving the values from it. Second one, what is the need of array traversal? So it is required in almost all the array related operations such as sorting, searching, and printing. So that is the concept. So we have discussed what is array, what are its memory representation, how they are initialized, how they are traversed. So what is base address, how to calculate the other parameters we discussed. And finally, before we conclude, in the next class, again, the some of the concepts of arrays, like insertion of an element into an array, deletion of an element into the array. So we'll discuss, along with the sorting and searching of elements we discuss. And that's all for the day. Have a wonderful day. And all class recordings, notes, PowerPoint presentations, everything is available in this particular website. Thank you. Have a wonderful day.